Hi there, my name is Rob Nertney and I'm a solutions architect from the Xilinx Data Center Business Unit. And today I want to show you a demo of our Alveo U50 accelerator card. Now the U50 is a half-height, half-length form factor card, which is capable of PCI Express Gen 3x16 or Gen 4x8 and utilizes high bandwidth memory. This card spans many applications, including storage, compute, and network offload. However, today I'm going to be showing you extremely high quality, real-time, low-latency video transcoding. Each U50 is capable of either encoding HEVC at 1080p 100, H.264 at 1080p 120, or it can decode H.264 and scale it for an aggregate of 1080p streams at 525 frames per second. Now, in order to get the best TCO savings, the U50 really needs to be populated into a server capable of housing many PCIe cards with the associated lanes to drive them, which is why this demo is utilizing the new DL-385 from HPE with AMD processors. The DL-385 is capable of housing 8 of these PCIe cards, and the AMD enables the ability to feed these cards the data they need. With AMD's Infinity Fabric enabling peer-to-peer, I'm going to be showcasing one card doing all the decode and scaling, while the other 7 cards are busy encoding these high-quality streams in real time. And we will then show demos of the adaptive bitrate scaler, which will end up showing us a full ladder of 1080p, 720p, 480p, etc. Streams to show for live streaming applications that you may need to run. So without further ado, let's get into the demo. So I've logged into my system here, and the first thing I'm going to quickly look at is make sure my cards are alive. So I'm going to do an LSPCI, and I'm just going to grep for Xilinx. As you can see, we have a lot of results here. Looks like a bunch of devices with 2 functions each. Functions are basically management and data for each of our individual cards. So if I quickly run this to account, we'll see 16 results, 2 functions per card, 8 cards, fully loaded, good to go. So next step here, what we're going to do is we're going to source the tool. And so what this is doing here is we will provide all the packages in binary form while still posting the source code on GitHub for your use, perusal, and licensing questions. Now, what we've done here is we've set up some of our utilities, the binaries for our utilities, into the path. We've also gone ahead and put our FFmpeg as at the top of the list here. So we should have our utility now, xbutil list. And as you can see here, it shows us some information about the system. We're running this on the Proliant DL-385 Gen 10 Plus and running on Red Hat Linux. And we have 8 cards detected with the current version of the firmware on it right now. So everything looks good. So what we're going to do here next is we're going to go ahead and do this XCDR control. Now this particular function here is just a script that you can look at, but the main purpose of this is to help define the system, because our video solutions don't just run on the U50, but today we are going to be using the U50. So we're going to need to identify this as -B U50. Now the pipeline is basically, are we going to be loading this FPGA with a 264 encoder or an HEVC encoder? So let's start with the HEVC. HEVC and C. And then N, the number of cards in the system. So like I said, we're doing 1 card for decoding and 7 cards for encoding, but this scales based on the number of cards your server has room for. Now what this has done is this has built a YAML file, which we'll go take a look at here. And this YAML file is a config that defines the system that we're going to be using. So you'll see here that we're using the firmware of Gen 3x4 2019-2. Where the binaries are, we're going to have 7 instances of scaler, 7 instances of decoder. This decoder bogus down here, this is just a memory arbiter. You should never need to use this or edit this file unless you want to customize where your cards are, and I'll show you the real pertinent points. If you have any questions about what the rest of these do, feel free to reach out to your HPE or Xilinx contact. But basically we're saying we have an image config, and we're going to put this onto device 0, one device. We have another image, which we're defining as the HEVC encoder, and we're going to put this onto the other 7 cards. And this is the function is encoder. So fundamentally, that's the end of the file. We're basically defining our system here as 1 card for decode and scaling and 7 cards for encoding. So now that this is set up, we run ffmpeg just once. And so without any flags, you'll see some of the build versions here. You'll see the flags that we did. The ffmpeg we have has no flags other than those needed for this particular evaluation or this demo that I'm showing you right here. But you're always welcome to compile with more flags, and we provide the source to do so. The important bit here is that it's loading that YAML file that we just went over, and now it's loading XCL bin to device. Now what this is doing is it's saying that each of these cards needs to be loaded with the programmable image that we defined. So we have 1 card, which is going to be the decoder and scaler, and the other ones are the encoder. Now this is going to take a little bit of time. And what's going to end up happening here is once we're done with this, all 8 cards will be programmed in a one-time thing for HEVC encoding. Okay, so now the FPGAs have all been programmed with with the proper HEVC encoder. So what we're going to do now is we're going to go into my directory, and we're going to go into, we'll just start simple here with the encode only. So what I've got here is, let's start, like I said, we're going to start with HEVC. So let's go ahead and look at my H.264 decode to HEVC encode.sh. Now what I've got here are some variables. The first variable is count. This is how many streams I want to run. Firmware, this is a firmware file, which is for our encoder. This is just a binary image that we load. We're constantly making improvements to our quality, and a lot of this has to do with some of the firmware that runs within the encoder. So this is just passing in a current binary blob of our firmware. Now the input here is just your standard, what file do I want to encode, which is going to be the good old big buck bunny from Blender open source clip. I'm going to remove my run logs here, as well as remove all the existing files inside my Apache web server. And I use this Apache web server only so we can actually come back to my Windows unit here, and we will be playing the videos through VLC. So you'll be able to see the videos, and if we are scaling them later in the demo, we will see all of those. We have just a for loop to run all of it here. We're going to run ffmpeg. Stream loop -1 is basically just going to keep running it here. The real meat and potatoes comes from us doing hardware decoding of the input file. The ng-codec 265, as if you aren't aware, Xilinx acquired ng-codec, which made very high quality live streaming encoders. And so this is the flag for their HEVC. 3 megabit, some flags, standard ffmpeg flags here. The adaptive quantization is showing that we will be pulling bits from one area of the picture and putting them into others, such that it looks much better. So we pull from non-interesting places and put them into the interesting places to make sure that the quality is top-notch. RC look ahead is just saying rate control. This makes sure that we look ahead in the future so we're ready for any massive changes or quality jumps that we need to be taken into consideration. We've got B level here, which has to do with our B frame usage, and then just that firmware, and then standard HLS flags. This is all ffmpeg. Really here, the only thing Xilinx needs to worry about is changing your encoder settings and your decoder settings. Then we pass everything into a stream, and we will pipe all of the output to a log. Now this little flag right here is just a little bit of housekeeping. This is saying that ffmpeg will not print to the screen. Otherwise, my screen will just get completely blown away with overlapping garbage. We're going to save it all to a log and then keep the screen nice and clean. And then we're done. So I'm going to quit here, and we're going to run this. So we're going to say 264 decode to HEVC encode.sh. And I'm going to go back and say I want Big Buck Bunny, 60 frames per second source. Need to grab that firmware file I was telling you about. And then from that, we're going to do HEVC encodes. And because each one is capable of 1080p, each U50 is capable of a 1080p 100, that means we're able to do 7 live streaming, high quality HEVC transcodes. So I will pop this here. Launched all of these guys off. We'll take a quick look here and do a top. And you'll see that we've got some FFmpeg instances that have fired off. So coming back here, we're going to go take a look, and I'm going to minimize my terminal here, come to my desktop. So what we're going to look at here is what I call encode.bat. This is basically just going to say enter the stream counts, and then for the number of streams, start up VLC from that web server, and we should see that I said 7 streams here. And you'll see that they're all going to bump up here. And what I'm going to do is going to right click on the desktop and show the windows side by side. So as you can see here, 1, 2, 3, 4, 5, 6, 7 streams. If I hit Control J, you'll see it's 1080p 60 coming in at HEVC. And so what we'll do here is we'll just maximize this so you can take a look at the quality. Remember, this is at 3 megabits per second, which is pretty impressive encoder quality running at 60 frames per second real time. Okay, so we're going to come back here. And what I'm going to do is we've got a lot more cool things to see. So we're going to close these out here. I'm going to come back to the terminal. Now that was encoding only. So one thing that we want to take a look at here too is the ability to do what's called an adaptive bitrate ladder. So within here, I go into my scale and I have another script. So I'm going to kill all FFmpeg because I put all those into the back. And while that cleans up nice and clean, we will do a vim of H.264 to HEVC. Now, same type of thing. How many ladders do I want to run now? Where's that firmware file and where's my source file? So as I scroll down here, do the same thing, little housekeeping ladder here. Same thing, we're going to go ahead and do a decoder with the Xilinx. Channel load is specific to the decoder. This particular flag says that you're capable of using one decoder instance and decode faster or slower or multiple streams within a single decoder instance. This is the default. We shouldn't need to change it. Now, the filter complex here is saying that we're going to split our 1080p into 2, and then temp is going to be scaled into 4 outputs. Okay, so A will be tagged, and we're going to say, oh, here's A. We're going to keep it at 1080p 60, 3 megabit, same flags, and send it out to a 1080p 60 manifest file. This is the HLS streaming manifest. Then we have temp, which is scaled to 4. So we've got at 1280 by 720, 480p, 360p, 240p. You'll also notice that we have rate full and then rate half. And so what we're going to do here is I'm going to leave this up for a second and then we can go through it. But fundamentally what we've done here is we've taken a 1080p 60 and we've turned it to a 1080p 60 out, a 720p 60 out, full rate, 720p 30, which would be the FPS of 30 here for the split. So we split B, which was 720p 60, into a 30 FPS as well. And then we have 480p, 360p, 240p. So if you have any questions about how to get this done, we will have it, of course, fully documented as to how to do these rates. There's nothing that says you have to do your standard 16:9 resolutions. The scaler is very flexible in doing portrait mode, different true 16:9s. So feel free to change these at your leisure. And as long as the aggregate is at 1080p, there's not a problem there. So we'll go ahead and close out here. I'm going to go to top and make sure that there's no more FFmpeg, which is good. And I'm going to go down here and run this thing. I'm going to say 264 to HEVC. Going to go grab that big buck bunny, 60 frames per second. Grab that firmware. And then now I have to figure out how many ladders I want here. So because we're at 1080p 100, we're basically able to split automatically 6 ladders across the 7 cards. And what this will allow you to do here is run all of these HEVC encodes you just have to call the FFmpeg command and we will end up arbitrating it for you. So what we're going to do here is we're just going to launch them all. 1, 2, 3, 4, 5, and 6. And what I'm going to do here is we're going to take a quick look at PS minus AUX grep FFmpeg. We're going to pass that to that count that we did before. So you can see here that we have 7 FFmpegs. And that is because with PS, it actually shows this command as one of them. So we have 6 ladders plus the actual search, which is exactly what we're looking for. So what we're going to do here is we're going to come back. Now we're going to launch this script right here, which is the same thing, a ladder count. And this is going to do the same thing here, and it's going to play as the 1080p, 720p, 480, 360, 240. And it's going to wait because I don't want to just overload my VLC because we just launched 7 streams, each with 1, 2, 3, 4, 5, 6 unique actual video streams. So I'm going to go ahead and hit ladder.bat. And I said I had 6 ladders. And what we're going to do here is take a look at all of these. And what you'll see here is that we've got all of the clips here in their various formats. So we'll bring this one back up. .720p, 720p. Put these just a little bit after each other here. And actually, I'm going to put these side by side again. And if we take a look at the data here, there's your 720p 60, 720p 30, 480p 30, 360p 30, 1080p 60, and 240p 30. So all of our streams are happening for stream 1. Close all these out here. And ready to go. And we will say I'm ready to show stream 2. 720p 60, 720p 30, 480p 30, 360p 30, and there's the 240p 30. And you can see here that once again, Control J, all the codecs are here, HEVC, 1080p 60. And this is coming across all of the cards. So I'll go ahead and close Windows here. I'll say stream 3. There we go. Stream 4. Stream 5. And stream 6. So as you can see, we're fully utilizing here, effectively doing 6 1080p 60 full ladder transcodes going through our HEVC encoder here. And now, so while these are going, we can come back to the terminal and take a quick look at the processors here. So if we go to HTOP, you'll see that only very few, we just have to maintain the thread count. We just have to make sure that all those FFmpegs are, doing the commands, because all of the DMA transactions, everything is handled either via peer-to-peer, card-to-card, and the only thing going back and forth between the system is housekeeping from FFmpeg. So you can imagine here that you don't need 128 cores. I mean, heck, you barely need, 8, 10, 12 cores on these systems here, because most of it is and handled entirely within hardware. So what we're going to do now is we're going to kill the FFmpeg. And while this closes up now, the next thing we want to try and do here is we can continue to do this. Right? Now we could say maybe we want to do the 1080p 30 with the firmware. And so we don't necessarily care. We can end up counting, we can bring this down to 720p streams and 480p and just dozens and dozens and dozens of streams. Just the more streams you end up having, the more threads you need to pay attention to. And we will have a full sheet of the supported and tested resolutions and stream counts coming up here. So this one, 1080p 30, that's half of the data width. So now we can come out and do twice as many streams. And so while this ends up going here, 6, 7, 8, 9, 10, 11, 12. And here we go. So we're going to go back down here. We were all done with this one, so we'll go back and do it again. And don't worry, we won't go through the whole thing this time. What I'm going to do here is show these windows side by side. Okay, and there we go. There's our full ladder. So we can go and do the codec here. 240p30, 360p30, 480p30, 720p30, 720p60, and 1080p60. So all of our streams are still here, and this is going okay, so now what we're going to do here is we're going to go back into the encoder only folder here. And what we're going to do is now we're going to go into the H.264. So we're going to go into the vim of H.264 to 264. We take a look at this, and what you'll see here is that it's pretty much the same thing. Still got the same hardware decode here, except the H.264 encoder from Xilinx is actually hardware accelerating the standard libx264 that we all know and love. So this is actually going to really simplify a lot of the command line here, because the libx264 library had what were called presets. Now, presets go from very fast to very slow. There's some mini in between and some extreme corners. But fundamentally, what this does is very slow enables all the tricks that libx264 know how to do to try and make your video be the most crystal clear that it can with the fewest bits possible. So with this comes an enormous amount of compute. So enabling all these tricks means it's got to think more and look further into the future and etc. So what it does is this is actually defined as being slow to do because it takes more time to actually run all this stuff. So all these presets are actually a bunch of flags hidden in the back, and you can search those on the internet if you'd like to see what everything is being enabled. But at the end of the day, the big feature is that you really won't get real time with this. And what we're going to see here is that with the Xilinx acceleration on the U50, we will get real time across the cards here. So what we'll do is it's otherwise the same flag. We're going to go and do that XCDR control. Just to remind us here, it's going to be XCDR CTL of the board, U50. The pipeline is now H.264 ENC, and the number of cars is 8. So that gave us a new YAML file. Just running FFmpeg up at the start here, what this is going to do is actually go and, once again, reprogram the H.264 encoder into the U50 rather than the HEVC encoder. Okay, so now what we've done here is I've loaded the FPGA with the H.264 image. So we'll clear out here and we'll do H.264 decode to H.264 encode. I'm gonna grab our good old big buck bunny here. 60 FPS, and remember I said we have 7 encoders of 1080p 75. So what we're gonna be able to do here is run one of these on every one of the 7 cards. So we'll go ahead and fire this off here. Let's see, launch stream 1 through 7. Now, as this is going here, you'll notice that we can toggle back and forth. We don't have to do an all or nothing. I kind of mentioned earlier that we're scalable here. So you could do 264 and HEVC. You can toggle them in and out as your workload requests them. Now what we're going to do is that grep command to see how many FFmpeg are running. And sure enough, remember it's 7 streams plus the actual search. So 8 is good. That's where we want to be. We'll minimize this and let's come back out here and do the 7 streams. And now this time around, what we should see is that it comes out as H.264. So give this a hot minute to get everything loaded up here. 1, 2, 3, 4, 5, 6, 7. Take a look at these codecs, 1080p 60, 60, 1080p 60, across the board here. So we'll go ahead and close these guys out here. And so this just goes to show that we're able to get all the H.264 on the fly, no server reboots required. We'll close these out. So now we can go into the scaling. So we're going to go down, we're going to go into the scaling, and we'll do the same thing. Let's kill all the FFmpegs. And now we will do H.264 to H.264. You can do 1080p 120. So we're going to go ahead and basically put those 6 ladders across the board here and take a look at what we can do. So we're going to go back and big buck bunny, 60 frames per second. How many ladders do we want to do? We're going to say 7 ladders. That will run everything across the board here. And we'll start this off. So while this is going, we will minimize, go to ladder.bat, and we will say that we will have 7 ladders. We'll let these load up here. And there they all are. Once again, H.264, 720p 60, 720p 30, and this will end up going across all of our streams here. And there are so many now that we won't necessarily go through all of them. So what we've basically done is taken the Xilinx Alveo U50 card and shown how on the fly we're able to load and unload different encoders, both of which are extremely high quality. HEVC for the massive bitrate reduction and H.264 for the compatibility of older devices. Now with this, you'll see that packing 8 of these into an HPE DL-385 combined with the AMD processor shows an astronomical amount of high quality density within this device or within this system. And with this bitrate cost reduction that you're going to start to see, in addition to your power reduction, the fact that it integrates so seamlessly with FFmpeg, these things all add up to an incredible TCO savings. So if you have any questions regarding this, please feel free to reach out to your HP contact or your Xilinx contact, and we would be happy to get you set up with this live demo as well, either on-premise or in the cloud. Thank you very much.